All right, we are learning about factoring polynomials. So let's just explain again what a polynomial is. Like if I had just 6x, that would be a polynomial, but that would just be one term. So it'd be a monomial. If I put 6x and then plus something else here, then that would be a binomial. And so on and so forth. Let's say I had like 7x squared, which is now, and then minus or plus 6x plus 24. Notice these are all three different terms. Like x squared is different than x to the first, and then this doesn't have an x. They cannot be combined. This would be a trinomial. And then anything beyond that we just call polynomial. Poly, the prefix means many. What we're doing today by factoring polynomials is factoring means you're going to take something and make it multiplication. So for example, if I had the number 6, if I looked at it as 6 as factors of 6, or there's many different factors of 6, but one way to factor 6 would be to say 2 times 3. So taking something and breaking it up into multiplication is the key. Well, we're going to be factoring a polynomial, so let me actually do this binomial here. What we have here is something that's not multiplied, so we're factoring it is going to make it multiplication somehow. The way it works is it's basically the reverse of the distributive property. So I'm going to just kind of set up the distributive property, put a little blank right here. And out here, what I want to do is write the greatest common factor of both of these numbers here. So what goes into 6 and what's a factor of 6 and a factor of 24? So like 6, there's factors of 1, 2, 3, and 6. 24, the factors are 1, 2, 3, 4. Man, I picked some numbers that have a lot of factors. 6, 12 are all factors, but what's the greatest common between them? Like 3 goes into both of them. 3 goes into 6, 3 goes into 24, but that's not the greatest one. 6 goes into 6 and 6 goes into 24. So 6 would be your greatest common factor, your GCF. Then it's like the reverse of the distributive property is to figure out what would go here to make 6x. 6 times what would make 6x. So it's just 6 times 1, x. And if you don't want to put the x, or I'm sorry, if you don't want to put the 1 there, that's okay. And then here, we got to make 6 times what would make 24 would be 4. So the final answer factored is just this. I don't put the 1 there. And now what we've done is we've factored and made it multiplication. This is one number times this quantity. They are multiplied, and that's what factoring means, is multiplication. Let me do another example here. Okay, and then so from here, I'm trying to find the greatest common factor to take out. That goes into 15 and 21. And 5 goes into 15, but 5 does not go into 21. 3 goes into 15, and 3 goes into 21. So 3 is our greatest factor here. So then it's 3 times what makes 15 is 5, but we got to make 15x. There we go. And then 3 times what makes 21 would be plus 7. And then that is the factored version. You can always distribute again and check your answers, but this is the answer right there. Okay, I'm going to do one more with some x's involved, a little bit more x's and exponents here. So let's say it was, let's go with 8x to the 4th plus, let's go with 24x to the 3rd. Okay, so we're trying to figure out what's the greatest common factor here between 8 and 24. And 4 goes into both, but 8 goes into 8, 8 goes into 24. So 8 is the greatest common factor here. But now with the x's, is how many x's do they both have in common? So from this has x to the 4th, so there's like 4 x's there. This has x to the 3rd, there's like 3 multiplied there. So the most I can take out of both of these, the greatest amount would be x to the 3rd. I can take out an x to the 3rd out of here. I can take 3 out of this one, and I could take 3 out of this one. So then, if I multiply this like the distributive property, and it's kind of working backwards here from distributive property, 8 times what would make 8x to the 4th? Well, a 1 to make the 8. And then x cubed, to get to x to the 4th, I need to multiply by an x to the 1st. The exponents are adding when they multiply. When these terms multiply, the exponents add, and that's how we get the 4th power. And then here, 8 times 3 would make the 24, and then x cubed times what would make x cubed? I don't need any more x's here, so there's nothing there. So my final answer could be written as, I'm not going to write the 1s here, just x plus 3. And if I distributed that, I could check to see that it comes out to be the same thing. Let me just do one more with the x's just so we can be sure. Let's say I had these. I can't combine them. They are not like terms. So I'm going to factor by pulling out the greatest common factor. So this one, you can think of it as like 15 x's there all multiplied. This one's got 5 x's all multiplied. What's the greatest amount I can pull out of both of them? I can pull out at the most here x to the 5th out of this one, and this one also I can take an x to the 5th out. So if I was to distribute this back, I got to make x to the 15th. So remember, you add the exponents, so it would, when they multiply, so it would be, that would make x to the 15th. And then to make x to the 5th, I've already got x to the 5th already here, so it would just be times 1, and then I would have the factored answer. So that's the answer. If I distribute this, it should look exactly like what we started with.